Hi, my name is Sara Arcos and my partner is Natalia Pinzon. We're going to explain our document about comparative variables of cardiac frequency, respiratory frequency, and temperature in horses before and after the exercise, and the physical degeneration and adaptation that they can get during the exercise, and the thermoregulation too. So we're going to start to see how we were able to do the experiment. But the first thing that we did was to take the variables in the animals as they were in column, to take the normal variables and get something to compare the other type of variables. So we take the first one like before the exercise and see what were the normal variables in those animals and if they were able to do it, because the animal have to be healthy to have a really good system to provide us the reality variables. The first thing that we did with taking the variables was to take the cardiac frequency. The cardiac frequency is usually taken on the left side of the horse in the first leg. That means that we need to have like an stethoscope to be able to hear how many times do we hear the cardiac muscles contract and produce the sound of a normal bump. So we count those sounds per minute, and we get a specific number that gives us the normal frequency of a horse, and we compare it to the normal statistics that we can find on the books. Later, we were able to check the respiratory frequency. This frequency we take it by the sound of the inhalation and exhalation of the breath, and we count how many times the process repeats in a minute, and that gives us a number. And again, we compare it to the variables that give us, like in a box with all these percent. And the last one was the temperature. The temperature in animals, as we know, is usually taken rectal. That means that we need to have like a thermometer and a specific one to be able to put it in the anus and wait about 1 minute to see if the temperature rise and how much did it rise in a horse. So we get like the number, and then we compare it to the variables that have in the book, like the normal variable.
It was started by taking the heart rate, temperature, and respiratory rate to guarantee the status of each of the animals evaluated, where these values were taken as reference to make the change and observe the compensation being evaluated. Consequently, an evaluation and verification was carried out that the horses were indeed in a position to do this by means of reference values extracted from an application for veterinarians, which gives the reference values of each species of animal by age, weight, and functional status, from which the standard values used to evaluate these variables were extracted. Heart rate is 28 to 40 beats per minute, 37.5 to 38.5 degrees Celsius, and generate confirmation of the optimal state of the animals. The exercise consisted of a half-hour routine where consecutive trotting exercises were performed with the same intensity of all animals in a closed circuit, together with the collaboration of 6 riders performing the appropriate command generated by a practice guide. Immediately after the practice, the measurements were taken again to determine if the variables changed and based on the physiological need. The table shows the realization of data obtained in practice that generate a confirmation that these variables are modified to generate a thermophysiological compensation. The heart and respiratory rate increases to release pressure, tension, and heat of the body of the animal to maintain a stable body temperature where the animal can continue exercising without having to worry about the internal temperature, since the same organism generates mechanisms of thermoregulation, and the altered variables help to promote the presentation of these required mechanisms. In any given case, these compensatory mechanisms would not be generated or the recovery system would not be performed in the best way. It would generate a warning signal for a pathological diagnosis due to poor physical recovery, which could lead to cardiac respiratory problems.
At the end of the experiment, we were able to determine that the frequency, respiratory and the cardiac frequency were higher because the body needs to overwork to get the same temperature, which is better for the animal because we always need like an homeostatic temperature that can help us. And in the end, we were able to determine it with the graphics that happened and that the animal have a really good thermoregulation thanks to the frequency of cardiac and respiratory, and they were much better functioning physiologic physiologic than the other type of variables.